Welcome to another Mathnificent conversation. It's your nerdy math bestie Lex here with another magnificent explanation. I hope you enjoy the conversation today. Today, our featured guest is factor by grouping. So, one thing that's important to know with all of the factoring concepts we learn is when do we use which method. Factor by grouping is only used when you have four terms. 1, 2, 3, 4 terms are being added or subtracted. That is when we attempt to factor by grouping. Now, just because something has 4 terms, that does not mean it could be factored by grouping, but it should always be the first thing that you try. Let's look at factor x to the third minus x squared plus 3x minus 3. Okay, when I first look at my expression, I have 1, 2, 3, 4 terms. So factor by grouping is going to be the first thing that I do. So we group together the first 2 terms and the last 2 terms. So by grouping, that just means I put them in their own individual set of parentheses. Then we factor out the GCF of each set. So in my first set of parentheses, the GCF would be x squared. X cubed divided by x squared is x. And x squared divided by x squared is 1. In the second set of parentheses, the GCF is 3. 3 divided by 3 is 1, and 1 times x is x, minus 3 divided by 3 is 1. Then we factor out the GCF again. So we can see both terms have x minus 1. So I can factor out x minus 1. From my first term, when I divide x minus 1 by x minus 1, I'm left with x squared. And from my second term, when I divide out x minus 1, I'm left with 3. So the expression we started with factors into x minus 1 times x squared plus 3. If you're still unsure about how to identify and factor out a GCF, please check out the Factoring Out GCF videos. Our next example, we want to factor the expression 5x to the third minus 10x squared plus 5x minus 10. The first thing I observe is that my expression has 4 terms. Because I have 4 terms, I'm going to attempt to factor by grouping. I notice I have 5, 10, 5, and 10 as coefficients. So I'm going to go ahead and factor out the GCF first. You do not have to. You could do it at the end. But anytime I'm approached with a problem that I have to factor, I check to see, can I make the problem simpler by first factoring out a GCF. So 5 divided by 5 is 1. So that's going to leave me with x to the third. 10 divided by 5 is 2. So that's 2x squared. 5 divided by 5 is 1. So that's plus 1x. And 10 divided by 5 is 2. Okay, I factored out my GCF. And now I have a 4-term expression that I'm going to attempt to factor by grouping. So I'm going to group together x cubed minus 2x squared and x minus 2. Okay, in my first set, what I like to do here is bring this down so the 5 doesn't interfere with my work. And I bring the 5 down to the bottom so I don't forget it in my final answer, but then I can focus on the factoring that I'm completing. So we know at this step, we're going to factor out GCF of each grouping. So in my first grouping, the GCF is going to be x squared, and I'm going to be left with x minus 2. Okay, then in my second set, 1x and 2 are relatively prime. They don't have a greatest common, or their greatest common factor is 1. You always have to factor something out. So in this case, 1 would be the greatest common factor, and then we'd be left with x minus 2 because something divided by 1 is just itself. Next step, factor out the GCF of the entire expression. Each term has x minus 2, so I'm going to factor out x minus 2. In my first term, I'm going to be left with x squared, and in my second term, I'm going to be left with plus 1. And so now I know my final answer is 5 times x minus 2 times x squared plus 1. Now we're asked to factor 2x to the third minus 10x minus 7x squared plus 35. So I do see that I have a 4-term expression, but I see that these two terms are not in order. You always want to make sure your terms are in descending order before you try to factor by grouping. So by descending order, the exponent on our first term is 3, then it goes down to 2, then it goes down to 1, and then it goes down to 0. Okay, I checked for a GCF, but 7 is a prime number. And then I'm left with 2, 10, and 35. So there's no GCF. These are all relatively prime. So we can start by immediately factoring by grouping. I'm going to group together my first 2 terms. And my last 2 terms. Notice the 10x is negative, so that negative should reside inside the grouping with the 10, not outside of the grouping. So now we know we're going to factor out the GCF of each grouping. In my first grouping, 2 and 7 are relatively prime, meaning the only common factor they have is 1. But x cubed and x squared, the GCF is x squared. So we can factor out x squared. In the first term, 2x cubed divided by x squared is 2x minus 7x squared divided by x squared is 7. Okay, in my second grouping, 10 and 35 are both divisible by 5. So the GCF between negative 10 and 35 would be 5. If this term is negative, you want to factor out a negative. And the way to check that is we know inside of our grouping we have 2x minus 7, meaning the first term should be positive and the second term should be negative inside of our grouping. So I know I need to factor out negative 5 so that once I factor that GCF out, the signs match. Negative 10 divided by negative 5 is positive 2. So that's 2x. And 35 divided by negative 5 is negative 7. So now we see what's inside our grouping is the same. So we know we're going to factor that out. So factor out 2x minus 7. And I'm left with, in my first term, x squared. And if I divide out 2x minus 7 in my second term, minus 5. X squared minus 5. 5 is not a perfect square, so it's not a difference of 2 squares. So we can stop here because both of our factors are prime.